Hey there, everybody. This is lesson 4711, and this is grade 5 EnVisions. Today we're talking about adding and subtracting fractions that are mixed numbers, and we've kind of gone through like the whole progression of this unit really has been like, let's talk about fractions and get them equivalent. Let's talk about adding fractions, just simple fractions. Let's talk about subtraction of fractions. Then let's introduce mixed numbers, so you have the whole and the fraction part. And then let's do addition of those. And now let's talk about subtraction of those. And now it's kind of like you're saying, okay, hey, you should know how to find common denominators of fractions, how to add and subtract them, what to do with the mixed number, and you can kind of put it all together to do a little more complex problems. And ultimately, that's kind of where we're at right now with those complex problems. We're looking at today in the independent practice, I'm just going to go over 15, I'll go over 16 as well. And hopefully these will help you kind of understand what's going on here if you need a little bit of a help or just a different way to think about it. I'm always a really big proponent of if I'm not helpful to you, find somebody else who is. And if you're coming to me from somebody else and you're like, wow, this Mr. Abbott guy is just kind of explaining it to me in the way that I can understand, that's great. That's what you should be looking for. Find something that's compatible. Not every teacher you're ever going to have is going to be able to reach you on every single level for every single thing, and you need to advocate for yourself to get to that point. So let's take a look right now at number 15. When we're looking at this problem, what I want you to think about is I want you to think about you really are kind of solving two different problems. Now, we're dealing with and thinking about order of operations here because we have these parentheses here and here. Okay, and these parentheses, they tell us that we need to solve this part first. That first we need to do this, and then we can add this part here. Okay, so this part is what we're going to start with, and we're going to bring this up. I'm going to put this up here and just isolate this section from this whole equation here and put this up here. So 2 5/8, and we're going to add 2 1/2. And so we're going to just deal with this. I can almost just not even look at this anymore. I just want to take a peek at this. Looking at this, we're following the steps that we know. Step number 1 is find a common denominator. And we have eighths and we have halves. And I know that if I were to go and I were to make lists of multiples of these numbers, I would get 2, 4, 6, and I would get 8. And I would start with my eighths, and I would say, oh, hey, look, there's eighths, and that's my common denominator. So I can tell myself I can just automatically use this. I don't need to change it into anything else. I can just use 2 5/8. That was easy, awesome. Now this 2 1/2, I need to change that into eighths. Now I don't need to do anything with my wholes. I don't need to change that into eighths. It's a whole. It's all good to go. So I'm going to bring the whole down, and I just need to change my half. So I'm going to do some work over here on the side. I'm going to put my half, and I'm going to multiply it by something to get eighths, right? Because that's what one common denominator is going to be. And I know 2 times what is 8. Well, I can count by 2s, or I can just know my math facts, but 2, 4, 6, 8, that's going to be 4. And so 2 times 4 is 8. And whatever I do to my denominator, I also need to do my numerator, so 4. So 1 times 4 is 4. And hopefully at this point you're kind of understanding that 4/8 is equivalent to a half. You can look at it to say, the 4 is half of 8. And ultimately, you can do that with any number. I don't want to get too crazy here, but you can think about it in terms of if I had 9 on top, well, what's going to go on the bottom? What's going to be double that? That would be 18, right? If my numerator was 7, what's my denominator to make an equivalent for half? It would be 14. So you're saying to yourself, whatever half is, whatever on top is, let's double that to go on the bottom. That's going to be half. So anyways, back to this problem where we were just dealing with this, and I said, in order to make my denominator 8, I need to multiply it by 4. So we have 4/8 equivalent, so I'm going to put my 4/8 down here. And sorry, it's kind of doing a funny connector thing here. I have 2 5/8 plus 2 4/8. I'm going to delete that. Oh, it's bugging me. 2 4/8, and I need to add those up. So when I'm adding these up, these are ready to go. I have my numerators are good to add, and my whole numbers are good to add, and ultimately it doesn't totally matter. Let's just add our whole numbers first. 2 plus 2 equals 4, so I put my 4 right here. And let's add our numerators. 5 plus 4 equals 9. So I have 9/8. So I got a total of 4 9/8. Now, I understand that a fraction like this one here is what we call improper fraction, right? And it's improper because the top number, the numerator, is bigger than our denominator, and so that doesn't work. So what we need to do is we need to break that out. So we could take that, and we'll do a little number bond on this guy here. If I take this out, if I take 1 whole, would be 8/8. That would be 1 whole, that's 8/8. And if I took out 8/8, I would be left with 1/8. And I can turn this, I can say that's really 1. And so ultimately I can say that 9/8 is equal to 1 and 1/8. Awesome. So I'm going to take that fraction here, 9/8, and I'm going to get 1 and 1/8. I'm going to add it to my whole that I had here, which was 4. And I'm going to get 5 and 1/8. Awesome. Good job. Now this right here, we're not done, right? That was not the answer to the problem. That was just the answer to this section right here. So 2 and 5/8 plus 2 and 1/2 equals 5 and 1/8. Okay, and that's what we got down here, 5 and 1/8. Put it up here, 5 and 1/8. And so now we can look at, I'm going to fix my 8 there. We can look at the rest of this problem, and I can just bring it down in here and minus 4 and 2/3. So you see how we just did some addition, and now they're asking you to do some subtraction, and they're saying, hey, you should know how to do all this by now. Okay, we probably do. So I'm going to delete all of this. It's going to take away my initial problem, which was 5 and 1/8. And so I can rewrite that here. So I have that 5 and 1/8 minus 4 and 2/3. So now we're doing the subtraction part. Okay, so let's go back over to our workspace, and I'll set this problem up. This is the second part of our problem, basically 5 and 1/8. And we're going to subtract out 4 and 2/3. And we're going to see what we get. Once again, we need to find our common denominators, and we have 8ths and we have 3rds, and so that doesn't work. They're not the same. So let's do our multiples. Let's start with the bigger number first. 8 and 16 and 24. We're probably going to be good with one of those, right? And I could do 3, 6, 9, 12, 15, 18, 21, and 24, and finally get up to 24. And that's going to be our common denominator. So I need to turn both of these. I need to make them both into, have a denominator of 24ths. So we're going to have 5 and something 24ths minus 4 and something 24ths. And I just figure out what those somethings are. So I'm going to do that math over here. I'm going to just do it in a different color so it kind of stands out here. So I'll do 1/8 first. And I'm going to do 1/8 first. I'm going to multiply it by something to get 24ths, okay? So 8 times what is 24? And if we just did it up here, we were thinking about that, 3/8 gave us 24. So 8 times 3 is 24. So 1 times 3, and do the same thing to our numerator up here, we get 3 and 24ths. So 1/8 gets turned into 3/24ths, and I'll put that down here as 3/24ths. Awesome. Down here then I need to also do 2/3. I need to turn 2/3 into 24ths so that I can do this problem. So 2/3, and I need to multiply it by something to get 24ths as well. And just like we just did the opposite here, 8 times 3 was 24. Well, that means that 3 times 8 is also 24. So I'll put my 8 in there. And 3 times 8, do the same thing to the top and to the bottom, numerator and denominator. So 2 times 8 would be 16 24ths. So I can add that down here, 16 24ths. So I have 5 and 3 24ths minus 4 and 16 24ths, and I can do that problem. Now, if we're going to do this, I do see something right off the bat. I'm looking at my 3, and I know I have 3 24ths, and I need to take away 16 24ths. And you can think about that in terms of, like, if I had 3 donuts and I need to give somebody 6 donuts, or 16 donuts, I can't do that. We need to take one of our wholes here, our 5. We need to take one of those away. And so if I were just to split this guy up into a number bond and take one away, I would have 4, and my fraction that I would have would be, since we're using 24ths, would be 24 24ths. That was a bad 4. I don't like it when it does that. It bugs me. 24 24ths. I did it again. 24 24ths. Okay? And so I have 4 and 24 24ths. And I also have this 3 24ths here. This 4 and 4 24ths right here, 24 24ths, that's 5. It's the same thing. When you add 4 and 24 24ths, that is 5. So it's the same thing. We're just renaming one of those as 24 24ths. We're adding it to the fractional component that we have so that we can take away 16. It's just like if I was borrowing, if I'm subtracting. Let's say if I have 53 and I want to subtract 16, I can't do that. I need to borrow from this to give myself one to put over here, right? It's the same kind of a thing, okay? Now it is different because the fractional parts make that math not the same, but it's the same concept that we're borrowing from something and breaking it apart and renaming it or regrouping. So we're regrouping this 5 into 24 24ths. I'm adding it to my 3 24ths to get a total of 4, and 24 plus 3 is 27 24ths. And yes, we have that improper fraction there, and that's what we want. That's going to allow us to take away the 16. And I'm going to subtract 4 and 16 24ths. Awesome. So I'm seeing 4 minus 4. I have those whole numbers. I need to take them away. 4 minus 4 is 0. Well, that's easy. Cool. So now I'm left with 27 24ths minus 16 24ths because my 4's are gone. And 27 minus 16, if you don't know that and you want to do that and line it up, 7 minus 6 is 1, and 2 minus 1 is 1, and that gives us 11 24ths. And that is our final answer because that was the second part of this. So I did this and we got 5 1/8. We subtracted out the 4 2/3, and we ended up getting 11 24ths. Wow, that was a pretty complex problem. That was pretty complex. I think you know, as long as you're taking your time on these problems are obviously going to take you a while to solve. This is not something that's going to be easy. I'm a math teacher, and that took me 10 minutes to explain and solve and go through. And so as you're doing these problems, I want you to think about that. Don't think that this is something that you can just rush through, get a quick answer, and be done with. And also don't think that it's something that if you're struggling with or you feel like it's taking an extra long time, well, that's okay. These problems are worth taking their time and doing them correctly. So let's ask ourselves one last thing, which is how could I check this to see if this is reasonable, if my answer was reasonable? So let's just do some quick rounding and see what we got. Excuse me. And see what we got. We have 2 5/8. That's kind of like 2 1/2, right? That's kind of like 2 1/2. And this is 2 1/2, which is a good benchmark fraction for us. So 2 1/2 plus 2 1/2, well, that's 2 and 2 is 4, and a half is another one. So that's 5. So I pretty much have 5. And this right here is like 4 and 2/3. We could say that 4 1/2. 5 minus 4 and 1/2. That's just going to leave me with a half. Is that a reasonable expectation? I got 11 24ths. Yeah, that's almost a half. So ultimately, I go backwards. I check to make sure that seems like a reasonable answer, and yes, it was. And so that's what we're going to do. That process. Do that process. And this last step is not necessary. You can just get your answer and move on. But in the end, it's in that kind of checking things to make sure that you're doing it the right way. And isn't that ultimately why we're doing this? I mean, practice doesn't make perfect. Perfect practice makes perfect. And so if you're going to be doing it, double check. Make sure you did it right. Okay. Well, I hope this helps. And I'm only going to do one problem. I said I was going to do 15 and 16, but I don't want to ramble on for another 13 more minutes and just do another one. If you want to check it out, I guess rewind and watch me do it again because I'm just going to do the same thing over here. Please, subscribe to my channel and let me know if this is helping you. And if you have questions, put them in the comments. I do listen and read your comments, and I hope you're all doing great. You got this. Just believe in yourself and advocate for yourself. Ask questions of somebody if you need to, and good luck. You're doing great.